I want to talk about solving inequalities. And before we go anywhere, let's just make sure that we're all on the same page. Inequalities are these four signs. We have less than or equal to, greater than, and greater than or equal to. These are the four inequality signs. And in general, you've seen them all before, and really the bigger one goes towards the open end, right? So one thing we could say is that 4 is less than 7. Simple, we knew that. 4 is definitely smaller than 7, right? So that's the inequality. All right, so the addition and subtraction properties, subtraction properties of inequalities are treated the same as the addition and subtraction properties of equalities. In other words, if I take 3 away from the left-hand side, I have to take 3 away from the right-hand side. All right, so then the multiplication and division properties of inequalities are different from the properties of equality only when you multiply or divide both sides of an inequality by a negative. Jolene, come on, darn it. Anyways, what I mean by that is if I have 4 is less than 7. Well, if I multiply 4 by -1, I'd have a -4. And if I multiply 7 by -1, here, I'll just write that here. Multiply by -1. So if I multiply 7 by -1, I'm going to have -7. Now, look what happens. -4 is a bigger number than -7. So because I multiplied by a -1 or dividing by -1, either way it's the same. I have to flip my inequality. This is very important. This is so important. I'm going to give it a star. I'm going to say this is the most important thing on this whole page. This is the most important thing that you're going to learn today. This right here. Whenever you multiply or divide two sides of an inequality, you have to flip the sign. Now here, I'm going to draw a little smiley face. Here is my smiley face. I have a smiley face, and then I want to give him some curly hair. Here's some curly hair. Okay. So I'm going to give you a challenge. I'm going to give extra credit for the first 10 Algebra 2 students. Now, mind you, that's 4th, 5th, and 6th period. But I'm going to give the first 10 Algebra 2 students to come to class tomorrow and have a smiley face on their page and tell me that when they multiply or divide and both sides of an inequality by a negative, they are going to flip the sign. Well, in order to get y by itself, I'm going to add 6 to both sides, just like we would an equality. 6 here. And now it says y is less than 9. And there's two ways we could write that. The first way we could do that, we could write that on a number line. Here we have a number line. And I could say, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, and here's 9. Okay? And I want to show all the numbers that are less than 9. Not equal to, but strictly less than. And for that, we're going to leave an open circle around 9, and then we're going to draw a line above, shading everything to the left, because we're talking about numbers that are less than 9. So an open circle means it's strictly less than. The other way that we're going to write this is using set builder notation. All right, so we're going to use set builder notation, and that is going to be the set of y values such that y is less than 9. And here these brackets here mean the set of y values, and this big bar right here stands for such that, and then you just put your answer and put the other closing squiggly brackets. So now we have the set of y values such that y is less than 9. Now let's try the next one. Something maybe a little bit more difficult. All right, so I have negative 4.2x is less than or equal to negative 29.4. All right, so I'm going to divide both sides by negative 4.2. That side by negative 4.2. And remember, when you multiply or divide by a negative, you have to flip the inequality. So this said less than or equal to, so I'm going to say greater than or equal to. And now I have x all by itself on the left-hand side, because that canceled out. And negative 29.4 divided by negative 4.2. We're going to have to get our fancy dang calculator out for that. All right. 20. A negative divided by a negative is a positive, so I'm just going to leave them positive. 29.4 divided by 4.2. 7. Oh, well, that was nice. Less than. Oh, I need my pen. So x is less than 7. All right, so let's show that. Or, excuse me. Whoa, whoa, whoa. Let's read this again. X is greater than or equal to 7. So here we got our number line. Our number line. And notice how many tick marks I'm going to put on this number line. Here's 0, and here's 7. All right, now here, since it's greater than or equal to, I'm going to shade it all in. I'm going to closed circle there, and we say everything to the right, because x is going to be greater than or equal to 7. And in set builder notation, the set of all x values such that x is greater than or equal to 7. Pretty simple set builder notation there. Okay, wow. Oh, so I have a c on the right-hand side and a c on the left-hand side. Well, let's clear that fraction first, because that looks ugly. So I'm going to multiply both sides by 6. And negative 4 times 6 is negative 24c. And remember, this is positive, so I don't switch my inequality. And then I have a 5c plus 58. Now I'm going to subtract 5c from both sides, because I want to get my like terms on the same side. Minus 5c minus 5c. Minus 29c is less than or equal to 58. And now I'm going to divide by negative 29. And divide this side by negative 29. And now I'm dividing by a negative, so I have to flip my inequality, so I want something that is greater than or equal to. And 29 goes into 58 exactly twice, but it's a negative 2. All right, so on a number line, we'll make sure we have our 0 position. And here's negative 2. And I want all the values of c that are greater than or equal to negative 2. So again, we're going to have a closed circle here. And it's going to go greater than to the right. All right, let's try. Oh, just a note here. Note. Greater than and less than has an open dot. Greater than or equal to and less than or equal to has a closed dot. Just like we saw with this guy here. Now we want to touch up on some factoring. I want to introduce this factor by grouping, and I think you've probably seen it before. Now, factor by grouping is you're going to have a 4-term polynomial. With that 4-term polynomial, we want to group the first 2 terms and group the second 2 terms. I want to include the sign of the 3rd term. And I'll show you a little bit more what I mean by that. And whenever you put the first 2 terms and the second 2 terms in groups, we're going to find the greatest common factor of each, and then we should know our factors then. Now, if there isn't a greatest common factor of the second group, then I can at least factor out a 1 or a negative 1. So I'm going to say positive 1 or a negative 1. And I'll show you what I mean by that in here in a second. Alright, so I have these 2. Let's factor these. And we want to factor these 2. 15x cubed plus 10x squared. When I factor these, my greatest common factor here, my GCF, my greatest common factor here is a 5x squared. The 15 and 10 both share a 5, and x cubed and x squared have an x squared in common. Now my leftovers, I should have a 3x plus 2. And between 12x and 8, I get 12x and 8 both share 4, a positive 4. So positive 4. And 12x divided by 4 leaves me with 3x. And 8 divided by 2 is a 2. Oh, now look. My 3x plus 2, 3x plus 2, those are the same. So that's one of my factors. And my other factor are the two greatest common factors that we pulled out. My 5x squared and my 4. So I should have 5x squared plus 4 times 3x plus 2. Now we could FOIL this out and see that the answer is 15x cubed plus 10x squared plus 12x plus 8. Here we have 10x cubed plus 4x squared minus 5x minus 2. Alright, so again, we're going to group these together like this. Ooh, that one's bad. So we want to group them together. These two are buddies. And I want to include my sign here. Excuse me, sorry. Now, the greatest common factor with these two terms. 10 and 4 both share a 2. X cubed and x squared both share x squared. And I have a 5x and a positive 2 left over. Now, 5 and 2 have no common factors, and 5x has an x and 2 does not have an x. So there's no greatest common factor that's really quite present. So I see here I have a negative. I've grouped my negative. I've noticed, hey, look, hey, there's a negative. There's a negative right here. This negative lets me know that I can at least pull out a negative 1. And what I'd have left over, negative 5 divided by negative 1 is a positive 5x. And negative 2 divided by negative 1 is a positive 2. So now I can see my factors that I have left over. I have this negative 1, 2x minus 1 times 5x minus 2, or 5x plus 2, excuse me. Oh, he made a lot of mistakes today. So 5x plus 2, since these two, my leftovers from my greatest common factors, since these two are the same, then that means I have a factor here. 2x squared minus 1 are the greatest common factors. Oh, there we go. So these two are my other binomial. And again, we can go through and FOIL this out and see that we would have come back to the original.